Hi, this is a supplementary Algebra 1 lesson, excuse me, covering lesson 84, graphical solutions in your textbook. I'll be working off of page 300 and 301 in your textbooks. If you want to open to that to reference this now, you can pause the video and get that set. So we've been doing this for a little while, and now this is a skill you need to develop in many areas, not just this math class, but it goes into science. It was integral to my engineering career. If you're going to go into any technical type of field, you need to get this concept of graphing functions down, okay? And we've been doing it by the method of coming up with a set of ordered pairs in graphing. Now that is coming to an end. There is an easier way of doing this. We're going to get into that starting the next lesson. Okay, but for now, this is a revisit on this old method of coming up with ordered pairs and finding a solution to a set of equations. So remember, a set of equations, and what we said there, they're joined at the hip, okay? So that the solution for x and the solution for y in this set for both equations is the same, okay? And we've also said when we see an expression as far as y equals x and something else here over on the other side, where it's only to the power of 1, x and y are in the equation and only to the first power, and there's some numbers we see, it actually graphs as a line, okay? So our drill was for this first equation, and we plug in I would say at least 3 points. Now some of you have been doing 2, and that's all you need to graph a line, but if you end up putting your solution in wrong for one of the points, your line will be way off. So if you do 3 points and you line them up and they line up, you know you've done them all correctly, okay? This is a skill you still need to develop, because as we get in, excuse me, they even mention in this lesson, if you read through it, looking ahead to forward lesson number 91, we start getting into equations that have a squared term in them, something like this, okay? And we're going to use that same method to graph it. Now there are many forms of equations with lots of weird variables to different powers and numbers added and divided in that, and we've been doing that in advanced math even, and it always comes down to the basic skill is plug several numbers into the equation and see how it graphs, and we're still doing that in advanced math, okay? That's not something you ever get away from, okay? So let's plug these numbers of x into this equation. When we plug a -1, we get a -1 plus a 1, y becomes 0. Okay, when we plug a 0 in for x, 0 plus 1 equals 1. And then when we plug a 1 in there, we get a 2. Okay, so let's go ahead and plot those. A -1, 0, a 0, 1, a 1, 2, 1, 2. We see they line up pretty good. I'm going to draw a line in there. I'm just going to kind of freehand it. That is our first equation. Let's plug in for here. Now, a lot of you guys are not showing work on this, and if you want to do this part like I did in my head, but at least show your ordered pairs so that I know you're doing that. You can go ahead and indicate the function over the ordered pair so I know which is which, okay? So I'm going to plug those same points into this one, okay? A -1 times a -2 becomes a 2, plus a 4 is 6. I get a 0. Okay, this becomes 0 times any number is 0. I get a plus 4. I plug a 1 in here. 1 times -2 is -2. Plus 4 is a plus 2. Okay, I'm going to go ahead and plot those lines. A -1 and 6. 1, 2, 3, 4. Of course, I only have 5 points on here, but it would be somewhere up here. A 0 and a 4. a 1 and a 2. A 1 and a 2. It's actually the same point that it was on the first line. I'm going to draw my line. Okay. And because they shared that same point, okay, what is the solution for the set? We set the solution is, when we do substitution or elimination, the solution is, you know, these are both fulfilled when x and y are the same for both equations. Okay, that is the solution to the set. Where are they the same for both of these lines? It's where the lines cross. And we said that the lines cross because we saw the 2 points are the same here, the bottom 2 points. X is 1 and y is 2. X is 1 and y is 2. Okay, x is 1, y is 2. That is the solution to that set right there. Okay, so if we did not know that, we would have to estimate where is that crossing. Okay, what points do those lines cross at? We would have to guess where that is on our graph. And that's the weakness of the graphical solution. Substitution and elimination give us an exact answer for x and y, and as we've been seeing, sometimes that comes up into a rather strange looking fraction, okay? But it's hard to estimate that exactly, okay, fractional wise on a graph, okay? It's just a real close estimation or guesstimation, if you would like, okay? I just want to draw your attention to example 84.3 at the bottom of page 301. 84.3, they have a set of equations, y equals x plus 2, y equals x minus 1. Okay, and if you notice in the example, when you go ahead and do your data points, your ordered pairs, and you plot the lines, the solution for 84.3 was 2 lines that were parallel to each other. They did not intersect. What is the solution then to that problem? We say they have to cross. That's the point of intersection. Is the point common to both lines? So that means the x and y value is the solution common to both equations. What if they don't cross? Okay, the answer is no solution. Okay, as strange as it seems, why would they give us a set with no solution? Just to test what you know. Let's confirm this now with elimination. These are kind of set up for elimination. I'm going to eliminate the x term. Of course, I have to multiply one of these equations by minus 1. Okay, I'm going to multiply the bottom one by minus 1, so that becomes minus y equals minus x plus 1. Okay, so I've got rid of that equation. I've replaced it with this one. Let's go ahead and do the addition of terms for elimination. I have a y minus a y is a 0 equals an x minus an x is a 0. A 2 plus a 1 is a 3. Okay, we come down to 0 equals 3. Is that a true statement? No. 0 does not equal 3. Okay? Therefore, this set has no solution. We've confirmed it with our process of elimination, or our method of elimination. If we come up with an untrue statement mathematically, the equations do not work out. The answer is there's no solution, because this is a false statement. 0 equals 3. False. Okay? So this set of equations, false. They don't have a common solution. We can't join them as a set. Okay? It's improper. It's mathematically a no-no. It doesn't work out. Okay? So we have proved that They proved it graphically. Now we could say, are those lines truly parallel, or are they kind of slanted toward each other a little bit? So maybe like, 1,000 units down on our graph, they might cross. If they're ever so slanted toward each other, they'll cross somewhere in the distance. We confirm it with that method there to see it. So, okay, so I hope that helps. This is our last lesson to focus on graphical solutions. Get that skill down. We'll be going into shortcut methods for graphing lines starting the next lesson. So shoot an email or a text message with any questions. So long for now.